Welcome back. So let's start looking at our first component that we need to know to start building our application is LangChain. Now LangChain on their website, they describe themselves as a framework for developing application powered by large language models. Now we know that all large language models nowadays, the modern ones, they provide their own APIs through which we can connect to their models and build application. So now question is, why we need another framework if the LLMs are already providing the APIs? So there are various benefits, and these are some of them. The first is the LangChain provide an ecosystem to develop the application. It's not just connecting to LLMs and chatting them. So what do I mean is, let's go to their website and check. Okay, so let's go to search engine and search LangChain. First link, go to LangChain. Docs, we are using Python, so we'll go in this section, go to LangChain, and on very first page, this is the diagram. So there are various component they have. The purple ones are, you see, it's mentioned as commercial because it is these are the paid services. And these ones at the bottom, these are the actual frameworks which are open source. Anybody can use it for free. And what we are talking about is the LangChain, which is the core framework for building any LangChain based application. Then with this, we'll be using integrations. Integrations are something through which you can connect to third parties. So if any other vendor comes with a new service and they want LangChain to connect to it, so they will provide the library for that. So this is again open source. And the LangGraph is open source framework for building stateful agentic applications. And this goes hand in hand with LangGraph platform. You build here and you do deploy here. Now, this is something we are not going to touch anytime soon. We'll see in future, probably we'll do the full agentic application using LangGraph, but not very anytime soon. On the right side, you see, this is a LangSmith. So LangSmith is another service which is provided by LangChain, and this is used for most important usage is the monitoring. So whenever we are sending queries to LLMs and LLMs are responding with the answers, if you are using just a chat interface, you don't know what's happening, what kind of message is going, what is coming. For day-to-day use as a normal user, it doesn't matter. But if you are developing application or maintaining application for large organization and which is crucial for their operation, then it is imperative that we should know in and out what's happening with the application, what goes in, what comes out, right? And this is where the LangSmith comes in. And this even though it's a paid service, they provide a generous free tier as well. So we'll have a look briefly like how to use it and what benefit it provides. So let's go back to our slides. Quickly discuss. So we talked about ecosystem. So now another one is the unified standard interface. So LangChain connect with a lot of LLMs which are nowadays spawning everywhere, and there are 100 plus of them, and it can connect with most of them. But benefit is that even though LLMs are different, their APIs will be slightly different, even though they are getting some kind of unification or some kind of standard developed for the APIs for the LLMs. But still, there are slight differences here and there. So if you're switching the LLMs, then probably you need to make changes to your code. And LangChain does that heavy lifting for us. And that's why it provides a unified standard interface regardless of the model. So switching models is just changing from, let's say, OpenAI to Anthropic, and that's it. You don't need to worry about what the API changes are behind the scene. Another is process coordination. Obviously, when you are building a commercial application, then just LLM will not do all the work, right? LLM is the brain of the application, but there's a lot of other things probably we need to do, like writing to database, reading from database, searching on the web, reading PDF documents, CSV document, sending emails, maybe sending SMS, reading SMS, so a number of things which is outside the premise of LLMs, and then only we'll have a full-fledged working application. So LangChain also provide components and services to help us do that easily, and this is where nowadays agentic applications are getting very popular, and LangChain makes it very easy to build them. Another is monitoring and tracking. This already I mentioned that this is where the LangSmith comes, and it provides facilities and services to do that. Last but not the least is the helper component. So again, it's going back to this process coordination. There's a lot of other external systems or external library services we would like to connect as part of our application building, and LangChain provides a lot of them. So it provides a kind of set of component called document loaders. So using document loaders of different types, you can load different type of documents. You can load HTML document, you can scrap a website, you can load a PDF document, a Word document, you can load Excel, you name it. So there are hundreds of them provided by community, and you can use it. Similarly, if you are consuming data from any other system or a response from LLM, the response may come in different formats. It may come in JSON format, it may come in Markdown format, right? And if you want to convert it into your, let's say in Python object, then LangChain provides something called output parsers. Using that, you can take the response and it will help you to convert into object that you have in your code very easily without writing a lot of code. So this is where it's very helpful. Now these are the fundamental concept one must know to build or start building any LangChain based application, and these are the ones we need to understand and know in order to complete our stock analyst application. So we'll start looking at them one by one. So we'll start with chat models first, and then we'll go through the list one by one. So let's do that. So I'm at the home page of the documentation LangChain, and from here I would go to integration, and on the left side you can see here components, chat models. If you click that, now here they list all the models, LLMs that LangChain can connect. So here you can see the provider. So it is Anthropic, Mistral, Fireworks, OpenAI, hosted on Azure, OpenAI, which is GPT hosted on OpenAI. So you can see, you can scroll through, and there are, I think, 100 plus different models that we can connect with LangChain. And the last column, you can see that what are the packages, because these are third party systems. That means it's not included in LangChain core. So we need a separate package supplied by the provider to connect to their system. So here, what is the corresponding packages that we need? So LangChain hyphen and the provider name, which is Anthropic, Mistral AI, Fireworks, OpenAI. This is what we need to install. So let's jump in the code and let's see how it works in practice. So first of all, let's first get into our project directory. So cd, okay, so cd desktop. So I've created this LangChain Gradio intro directory already. So for every project, as I said, we are going to create a new directory. So this has been created. And in this, I have already created a virtual environment, right? Before that, the first thing, as we saw in the setup video, that we have to activate our Python version we want. So py-env, if we do versions, then we can see I have this activated. If it is not activated, then we have to do py-env local and the name of the Python version is 13.2, right? So this is how we activate it. This is step number one. Step number two is to create the virtual environment if it's already not there. So the command is python -m venv dot venv. So dot venv is the name I am giving. You can give any name you want, and we just run it. So I'm not going to run it because already you can see I've already created this environment, right? Okay, so next thing is first thing we are going to try is, as we discussed in second video where we discussed about large language models in detail, we discussed that there are two flavors broadly. One is hosted by the provider in cloud through which are generally paid, like OpenAI, be Google Gemini or Anthropic Cloud. So these services are paid and hosted on cloud by the providers, and you need to get an API key, and through that you can access. Other option is that you can run your models locally through Ollama, right? So that's another option. So now the open source large language model ecosystem is growing very fast, and they are becoming better and better every day, but definitely not at the level where the paid services are, right? Because there's a lot of money thrown in there. So but in general consensus is that in few years time probably they'll be at par. So what we are going to do is we are going to use Chat Ollama, which is Ollama version of local models, which we are going to download and run on the local machine, right? So there is no cost to it, and there is no API key, nothing to be paid. And for that we need LangChain Ollama package, number one. Number two, we are also going to try a frontier model hosted by OpenAI. So for this we need LangChain OpenAI package. So let's do that. So I'm here. So before I install them, I need to activate source dot venv scripts. Okay, now let's do pip install LangChain Ollama and LangChain OpenAI. So these two. Okay, so in venv environment we installed it. In my case it is saying requirements already satisfied because I've already got them. So that's why it went very fast. In your case, if you're doing first time, that might take some time. Another package which we need is python.net, and this is the package that allows us to load the API key as the environment variable for security reasons. It can be so that we can access the model without exposing our API key. So again, we are going to do pip install. Name of the package is python dot n, sorry, not .net, .n. Okay, so again I have got this, that's why I'm saying requirement already satisfied. So packages are done. Next is for running the local version of software, local version of our models. We need to have those models downloaded. So let's do Ollama list, right? Now in second video where we discussed the LLMs, we have gone through how to install Ollama and how to install the models as well, right? So if you have installed models, then Ollama list command will list those models, and the installation is pretty easy. So you do Ollama and command is pull, and you give the model name. Okay, this is the model name, right? So if you're not sure about Ollama and how it works and how to do the installation, install these models locally, then please go through the video 2, which is introduction to LLMs, and the link will be in the description below. So please check that out first. Okay, so I have got these models there. So this is sorted. We have got our virtual environment, all the required packages done. So let's go to VS Code and try to see. Okay. Now before we start, I want to mention this. OpenAI key, API key is here, and Anthropic API key is here, and it is held in the .env example file. But actually, um, in the real projects, it will be held in .env. In fact, my real OpenAI key and the Anthropic keys, everything is here. But I am not going to show it because they are secret, and if anybody get access to that, they can use it and I'll be charged, right? So that's why I have, just for demonstration, I have created this env example, and these are the dummy keys. Okay, so if you want to access OpenAI models, then you have to define OpenAI API key equal to, and this, where within the quotes you have to provide the API. Similarly for Anthropic, this Azure thing, I'll go a bit later what this is. This is actually that I'm going to use, but let's not worry about it for now. So let's try the Olama one. Olama one, you don't see any Olama key because Olama is running locally, so we don't need it, right? So this I'm just mentioning, if you want to use a frontier model that is paid, then you need API key. Okay. So, and again, I specified that these things are actually to be held here in .env file. Not, this is just for demo purpose so that I can show it. All right, so let's start. So first I'm going to create a file, Python file. I'm going to call LangChain, which is lc concepts .py. Okay, the moment I did it, you can see here that it selected the latest Python version already. All right, now let's start. So I'm going to cut and paste some code here. So first I'm going to import. So because first we are going to try Chatolama, so I'm going to import Chatolama class from the package we just installed, and also I'm going to import .env package, load.env function. So this will help to load all these variables into the environment of the system so that we can access later on. How do we execute? As we saw, we are going to use interactive shell. So selected all and shift and enter. All right, so true means it's successful, everything is good. Now let's try to connect to Olama. Now this is the code. It's very simple. So we are going to instantiate this class Chatolama, and the temperature is optional parameter generally, but it's a good idea to provide a temperature. Generally 0.7 works okay if you are going to need a response from the model which is factual, as well as model can be a bit creative. If you take it to 0, then it's not going to be creative. It's a very dry response you'll get. The another parameter is the model, which is the name of the model. This is the mandatory one. Temperature we can give let's say 0.5. Now let's run this. Let's run it from beginning. Okay. All right, so let's check what is LLM. So this is the instance of Olama class. Now let's query the model. So I'm just going to put here. So this is the question I'm going to ask. How far is the Earth from Sun? Okay. Now here's the response. You can go through. So basically, it's a fact-based, whatever is there in its knowledge base, it gives the answer. So this is how we interact with Chatolama. Now in case of, let's say I want to connect with OpenAI frontier model, right? So in that case, we have installed the package already. So I'm going to import it first, and then it's a very similar code Okay, it's a very similar code. So this was chat Olama, this is chat OpenAI, similar parameters, temperature and model. The only extra thing is API, because it's paid model, so you have to use your API key that you got from OpenAI when you registered or subscribed to services, right? And this environment variable is read from, as I mentioned initially, from here. Okay, and this is being loaded by load.env. That's why we can access. So now this error is coming because I need to import OS. All right, so let's try this one. So I'm going to run this whole thing again, and instead of Olama, I'm going to create this. Okay, sorry. So actually thing is, I don't have subscription for GPT model hosted on OpenAI. All right, so that's why it's complaining about API key. So I use OpenAI model, but hosted on Microsoft Azure services. All right, so it's the same model, but it's not hosted within OpenAI infrastructure, but it is hosted on Azure clouds given by Microsoft. The advantage that there are people and customers, they ask for their data to be private, right? So when you access chat OpenAI directly from OpenAI, then I think now they have improved it, but initially, till very recently, it was not very clear that which instance we are using, whether it is private to me or not, where my data is going and all this. So what Microsoft has done, they have taken copy of OpenAI's ChatGPT model, they've hosted on Azure, and you can subscribe to have your own copy of the model. Okay, so there is no difference, the same model. The only thing is the way we connect is slightly different. So instead of chat OpenAI, I use Azure chat OpenAI class. So from here itself, I import this one and I run it again. So temperature is, I can keep same, say 0.5 in this case, and API key is again, I have got API key provided to me by Microsoft Azure service, so it is stored here, Azure OpenAI. Okay, apart from this, when we are connecting our model to Azure, we need to provide some more parameters, right? This is because this is a private copy of the model, kind of logical copy. So it has different endpoint, HTTP endpoint to access it, and I have to provide the version and the deployment ID and all, right? So this access method is slightly different than this, but actually same thing is happening. Instead of connecting to OpenAI, I'm connecting to Azure. If you are using chat OpenAI directly, just do this. Okay, and since I don't have subscription directly with them, so I'm using this. That's it. There's no difference at all. Okay, now let's try this one. So this gave me error. All right, so this is successful. And now let me ask the same question. Okay, so I got the answer. So this answer is coming from OpenAI hosted model. Okay, and the model which I am using is same GPT-4o mini, which is the latest but the most cheapest instance, cheapest model from OpenAI. This is what I've got deployed, and this deployment ID basically points to this same model here. So again, if you are using OpenAI, just use this thing. Okay, it's very similar to chat Olama. Okay, there's no difference. So as you can see, accessing different LLMs, and similarly, if I have Anthropic, then I'll call chat Anthropic, and exactly same parameters, only the model name will change, and I'll be able to access Anthropic. So regardless of their API, their internal implementation, LangChain takes care of it. So I do not need to worry about which model I'm using. Okay, so that's the whole concept of providing a unified interface that we talked about earlier. Okay. Now the next part is we are going to talk about this bit. Okay. So this is, even though we are sending a string, the model, they do not accept the strings directly. They accept the any user text or query in form of messages. Okay. And internally what LangChain is doing, it's taking this string and converting into the suitable format for the model. Okay, so if I have to show you the message, so in OpenAI API documentation, if you go to platform openai.com, or if you just search OpenAI API reference and you come here, go in text and prompting, then you can see what kind of this input is the input that model expect. See this one, right? So there are two key elements here. One is the role, which tells us what type of message I'm sending. So now in the latest version, they are calling it this developer, but in earlier version, it used to be called system. All right. Another one is the role, user, and this is the user message. So user message is the message that we are actually interested in. We are sending to model. This developer system message is kind of setting the context for the model. That means setting the persona, like how we want model to behave, how we want to respond in a particular way. If we want to restrict this model to do only particular things we want, right? So this is setting the context and the behavior of the model. Okay. And this is the message that we are sending, interested in, and we are interested in the getting the answer for these messages. So this is the structure. All right. But in LangChain, I'm just sending the string, and it is basically behind the scene, it is converting it. So behind the scene, actually this message, if you look at the response, if let's look at the response. Okay. So if you look at the response which I got is the AI message. Okay. So primarily we are interested in two types of messages. One is the system message, which sets the context of the model. Second is the user message, which is our query, which is this. Now in this case, we are not doing system message here, but we'll get into that soon. And the third part is we are interested in AI message. AI message is something that we receive from the model. This. So what LangChain does, it receives these messages, okay, and it converts into their respective Python classes. So for AI message, the Python class is AI message. Okay, that's the output from the model. Okay. Okay. So this. Now we will try different queries in a different format. So right now we talked about the messages, like how the model expect message to be formatted in a particular way, and the LangChain converts into that format, right? Now LangChain builds another abstraction on top of messages is called prompt or prompt template that makes it very flexible for us to build the application and soft code a lot of things, so that we can substitute at the runtime. So single prompt will be built, and at the runtime we'll take input from the user and substitute in the message which we are sending to LLM. Like for example, if you remember our stock analyst app, there we are taking input as a stock symbol, right? So prompt to the model is same. The only thing we are substituting is this stock symbol we are putting inside the message, and then we are sending it. And LangChain makes it pretty easy to do that using something called prompt template. So this is what we are going to do it. But instead of putting all the prompts here going forward, what I am going to do is I am going to put the prompt in separate file. So let me change the prompt templates. Okay. So let me create a new file called prompts.py, and these are the prompts already I have prepared. Okay, so I'll clear this side first. And this is what we are going to use. This is the first prompt, this one, same thing which we used. So what I can do is I can import it now. Import prompts, and then I'll run it. And then instead of this message here, I can do prompts user prompt 1. So this is the same thing, user prompt 1. It's the same thing basically. It will return me exactly same response. Okay. Now, what are prompt templates? So prompt templates are templates that's used to format the messages. Now you might be thinking what that means, right? And you're right, because first time when I encountered prompt template, I got terribly confused. So let's look at it step by step. So first of all, we know that all the LLMs, they do not just expect a plain string or text in their input from their APIs. What they expect is a well formatted message. What it looks like, we have seen this in video 2 when we discussed LLM in detail, but let me just go over again one more time. So different providers, they provide different APIs, but nowadays the kind of APIs more or less looks very similar. So what I'm looking at is the OpenAI API, and you can reach this page by just search API reference OpenAI and then come to text and prompting, and then you can just look at and you will see the message roles and instruction from here, right? So this bit which says input, so input is a list, so it expects a list of messages, and each message must have two component at least. One is the type of message which is called role. In this case, role is developer. Here in the second message, role is user. So up to very recent version release, this first one is used to be called system, but now I think they have changed it to developer. So basically this role is a message that specifies how LLMs should behave, to setting up the context or setting up LLM persona. For example, I want to restrict LLM to respond only in Markdown, and I want to answer questions only related with, say, let's say soccer. And if anything you asked other than soccer, it will just say, I don't know. So this kind of instruction I can give upfront. This is one-time instruction given, and then LLM persona or kind of behavior is modeled or set based on this developer or system message. Now user is basically user message. So these are the actual questions which will be sending to LLM for their answer. So this is how the actual messages they need in their input. Now, but in LangChain, we do not need to format this like this, because LangChain has built in its own abstraction on top of messages, and these abstractions are called prompts. That's what we are discussing. So here is one class LangChain defined, which is called chat prompt templates. And if you look at it, the way it is prepared, it is very similar to what we looked at, right? System, which is now called developer in OpenAI case, system and user. And we wrap it around a chat prompt template class. Then we prepare a template and then we format it. So it may not be making much of sense. We'll see in the code, then probably it will be much clearer. So basically what's happening is we are defining a template, and the user one is soft coded, just like Python f string. So topic is a variable, And at the runtime, I can pass the topic. So in this case, topic is cats. So LangChain is going to format this message using this invoke command, where this cats will be substituted here. And thus finally, when LangChain is sending this prompt to LLM, it will format to the message format for that particular LLM. So if it is OpenAI, it will be in OpenAI format. If it is Anthropic, then it will be Anthropic, Gemini, and respective format. So that we do not need to worry about. What we need to worry about is just defining a chat prompt template. Now, you might be thinking, and rightly so, that why this go to this difficult route of just formatting message. Why can't we use Python string manipulation, string substitute, and f string or format, Python format function? We can definitely do that, but using these classes gives us lot of flexibility, and later on you'll see that using these classes, it's very easy to build complex chatbots where we can manage memory and history, right? And if we just use simple string, then probably we have to do a lot of work, which LangChain has got built-in plumbing for that. And that's the whole reason why we should be using the chat prompt template. So let's jump into our code. Okay, so very first thing we are going to do is we are going to import chat prompt template. We have already imported all the prompts here. This is just to not to clutter the code. So all the string and actual prompts are here, and we'll go one by one through them. Okay, so once we are done with this, let's try our first prompt. Okay, so what I am doing is I am invoking prompt. I'm getting this user prompt2 from prompt file, which is prompt2 is this. Now you can see that this is a message which has a kind of placeholder. This is the variable. Now in the first one, it was hard coded, for example, sun. Now in this case, if I want to find out distance between Earth and Sun, Earth and Saturn, Earth and Jupiter, then instead of writing separate messages and sending it, I can create a flexible soft coded message and use it. That's the whole point of prompts. So how it is working? So chat prompt template from messages, and what are the messages? So obviously we have seen two types. One is system. So in this case, system message, we are not passing anything. So we leave model to decide how it wants to respond. And then another is the human. So in OpenAI case, this message type is called user, but LangChain calls it human. And behind the scene, actually using this, this is a list of tuples, right? First is the type system. Second is the actual message. Here type is human, and here's the message, right? Behind the scene, it creates message classes. So this will be system message, this will be human message, and the response which we get back, which you have already seen, is AI message. These are the classes that LangChain will create behind the scene, but this is the easier. So you just provide system and message, human, and just message. Okay, so this prompt is done. So let's try to execute it. So first let's execute the import. So this is done. Now let's see what happens here. Okay, so let's examine this guy. Let me clear this. So if we make more space, so if you look at it, it is chat prompt template, and important thing is you can see the variable is body, and this is nothing but this guy. Okay, and another message is human message, right? Input variable is body. Okay, so once we have created this template is actually made concrete by formatting it. And the way to format LangChain prompt template is using the familiar invoke method, where we provide the value of the variable we have already defined in the message. So if you look at this prompt 2 here, body. So this exact thing we are going to pass as a dictionary key when we are invoking. So just see what happens. And now if I see prompt, now you will see it is more concrete. So in this case, it was the same message which we have defined with the soft coded variable. In this case, there has been substitution. So what is the distance between Earth and the moon? Yes. And from there on, it's same. I mean, you can just call it and you'll get the response. The same thing. So now it's Earth and moon is giving the response about Earth and moon. Okay. So that's one way of using the prompt template. So first we create the template and then we format it by passing the variables which we want to substitute, and then once the prompt is formatted, we pass that prompt to LLM. Okay, now let's try this guy, another flavor. So in this case we did not provide any system message, so in this case I am providing a system message. So what is system message? So here I'm basically defining how the model should respond and what is context and what we are expecting it to respond or not respond to. So I'm saying that you should only respond something about cricket. So if it is anything outside the game of cricket, then you should not be responding. Thus I'm defining the persona. This is the system message. So system, same, and instead of here it was blank, now I'm passing the system message, which is soft coded, which is not soft coded, which is hard coded, that's saying that it should only respond to cricket, then human, and prompt 2. What is prompt 2? Prompt 2 is same thing which we used last time. Okay, so now let's try again. So clear this one, do this, quickly see this guy. So now you see the message. What is the message? So system message, the model behavior, I have specified that you are a helpful assistant with expertise in cricket and you should not respond any other question other than cricket. But question what I'm asking is, what is the distance between Earth and moon? Let's see what happens. Okay. Oh, let me print it. Now, because of the persona what's saying, I'm here to assist you with cricket related queries. If you have any other questions, feel free to ask. So it is following my instructions. So now I'm guiding model to do something very specific rather than leaving it to do whatever he wants to do. That's the whole point of system message. Okay, and that is also soft coded, as you can okay, in this case it's not soft coded. Next example we see we can soft code system message as well. So this one. Okay, so now here I'm using system prompt 2. System prompt 2 is same message, but here I'm defining that instead of hard coding that you can only answer question about cricket, I'm leaving the domain or field of expertise as a variable, so it is soft coded. Okay, and rest is same basically, similar. So and human prompt 2, I'm using prompt 2. So prompt 2 is same which we used previously. Okay, so now if we format, because there are two variables, one is the domain in system, another one is body in the human, and that's why you're passing two dictionary keys while formatting it. So do this, clear, let's view this. So if you see, So your helpful assistant expertise in with expertise in cricket status. Why cricket status? And didn't we execute this? Oh, I didn't do this, is it? Oh, okay. All right, now it should be okay. Yeah. So you are an expert in the field of physics, which we are passing, and then we are asking a physics question, right? So let's see what it does. So let me copy this as well here. And let's see. Let me clear this. See this. Now it is responding. You remember that in previous occasion it says that I don't know because we said that you are cricket expert, right? So that's how we hard codes. Now you can see that when we are building the apps, these variables, they can be user inputs. Like in case of stock analysis app, one of the variable we are going to use is the stock symbol, which is not known when we are building the app. That will be provided by user, and that's why we can use this method to soft code the prompt and create a dynamic kind of message for the LLM. Now let's try one more. Just ask a cricket question. So user prompt 3. So user prompt 3 is asking a cricket related question, but the what type of cricket match is left to be decided by user, which is soft coded. And this is what we are going to provide us. So in cricket, there are generally 3 types of matches are played. One is the 5 days matches, which are test cricket. 1 day matches are called 1 day international ODIs, and there is a 20 overs matches called T20. So there are 3 types. So I'm asking who holds the record for most run in particular type of cricket. Okay, so this is soft coded. So let's do this. And domain I'm specifying cricket, and type I'm giving ODI. And let's print this as well here. Let's run it. Yeah. So it's saying Sachin Tendulkar has scored. I think it's still correct as far as I know. But if you see, it's very clearly saying as of October 2023. Why? Because the training data which has been used for this model is up to October 2023. So it's not going to internet and searching, right? And that's the whole point. So LLM will provide responses based on its training data. They cannot go beyond that directly. So that's where the framework like LangChain are useful, where you can build application around and provide additional functionality to your application, which we'll see in future videos how to do that. Okay, so this is done. Let's try one more. So if I test, consider this as a user interface where user is selecting type from drop down. Okay, so first he wanted to know about ODIs. Now he wanted to know about test cricket. So same prompt. So I do not have to redo the template, only this prompt. Run it. And you'll see most run in test cricket. So again, Sachin Tendulkar saying as of October 2023. So that's the whole concept of prompting. So they are built on top of messages, and they provide extra functionality and flexibility that can be used to create complex applications. That's the whole point. Okay. Now, one more thing you must have noticed is when we are building the prompt, we are doing it in two steps. One, we are defining the template, right? And then we are formatting the prompt using invoke, and then we are calling LLM invoke. Okay, so there are three steps involved, right? And then I am printing it, extracting the content from here. So generally 3 or 4 steps. Now LangChain provides a capability or functionality to create a pipeline of steps, and they are called chains. Hence the name, initially it was given LangChain. Okay, so you can chain various steps to create a complex pipeline to follow step 1, 2, 3, 4. So in this case, okay, so create chain. It's very simple. So chains are created using, in latest release, they have provided this something called LangChain expression language, LCEL. Previously, you would need to call instantiate objects and call functions or enable functions, but now it's not required. It's pretty simple. So what I can do is, the previous example, I can do a chain and I can create a chain. So what's the first thing I'm doing? I'm doing this, right? Prompt template. All right, and then output of prompt template goes to my LLM. Okay, so let's try this, and then I can invoke from the chain itself. So 2 steps combined, and then I invoke this same thing here, and then here. Okay, so instead of content, yeah, right now no. Okay, so clear. So first I do this, create a chain. Let's look at what's chain look like. So if you look at it, it creates a complex object where LangChain takes care of all the plumbing behind the scene. Invoke method here, taking the output, feeding it to LLM. Okay, and then taking the output and returning it to chain. That's how it works. So you can call this, let's make clear, run. Okay, now this chain can be as long as you want, if provided your elements or component which you're using, they are following certain standards that is specified by LangChain. Okay, so I think generally one requirement is that they need to have invoke method implemented on them. So I can extend it. So let's say let's do a very simple add a simple step. So I'm adding something called output parser. This is one of the additional functionality provided. I'm using a string output parser. So basically what this does is it consumes the response from LLM and it extracts the meaningful string response, text response from the LLM. So let's first execute this, and then what I can do is I can chain it. Str output parser like this. So once I do this, I do not need to do this content thing. Why? Because in response, I'm going to get text directly. So you see, first prepare that prompt template, format it, then pass it to LLM, get its output, pass it to parser, it parses it, and I get the response in text. So this is a simple example, but similarly a long complex pipeline of different steps can be created. That's the whole point of chains. same response, but in this case difference is that I do not need to extract text manually. Now in this case it was easier. Dot content in some examples where the output of LLM is not in a very simple format, then string output parser will help you to extract the text easily. And there are various other output parsers are there that probably we'll see in future videos. So this is about LangChain prompt template, messages, and chains. And this is what we need to know as of now in order to proceed for building our projects. All right, so we have looked at chat models. We looked at what is chat prompt template and messages. We experimented with them. Then we looked at what is output parser. We just looked at one of very simplest string output parser for now. And then we looked at finally at the chains, how to combine all these to create a some kind of pipeline multi-step process using LCEL, which is LangChain expression language. Now the last item in the list is the LangSmith. So LangSmith, as I explained earlier, is not a part of LangChain framework. It's a service provided by LangChain, and it is a paid service, but they also provide a free tier for experimentation for developers. So let's have a look. This is basically used for monitoring and tracking purposes. So we can see our messages going in and out from our code to LLM and literally see what's going on. So let's have a look. So, okay. All right, so let's search quickly. Yeah, I've already searched. So search for LangSmith. Then the first link, go here and then click sign up for free. So I have already signed up, so it directly brings me up to my home page. But for you, if you have never created an account, as usual, it is going to ask you for email, and just select your email. Signed by Google is the most convenient one. So once you're done, then you'll end up in this page. And then from here, the first thing we are going to do is go in settings, and then initially I have already created my API key. Like any other service, this works on API as well. So since it is a paid service, so you need a API. But initially, since we have signed for free, so 5,000 traces are free. So that means 5,000 messages to and fro are free, which is enough for experimentation. So you won't be charged, and it doesn't ask for your credit card unless you cross 5,000 threshold. So you come here, and then if you don't have an API key, then you provide a description, keep it personal access token, and create the API key. So I have created here, and remember, like any other API key, you will be able to see only once. So you must copy your API key and keep it safe. Okay. So once that is done, let's go to our code, and we need to set up these environment variable. So obviously the obvious thing is it should be named exactly like this, LangSmith API key, and you paste your API key just now we created within the code. Then LangSmith tracing true. I have put in quotes, it's not required, but if I don't do it, then my linter gives me some kind of warning. So just to avoid it, I've done this. You can do like this, or you can leave it, but it's a bit annoying, so I've done like this. And then you define your project. Now this can be anything. Okay, so you define the name of your project depending upon your convention or your how convenient it is. And then this is constant lang. This is not really required. I think it works without that as well, but they have given in the documentation, so I'm putting it here. So just define this as well. So save it. Now obviously I'm showing this in .env example file, but actually you have to put in .n file. Okay, once you're done with this, go back to your code, and then you have to reload your .env. Best thing to do is, if the interactive shell is already running, then you must close it and then you do it, so that making sure that loads your new environment variable. So in our case, I don't have interactive shell, so I'm going to run it. Now everything must be loaded. Okay, then since I'm using Azure, so I'm going to execute this one. If you are using OpenAI, then you have to execute this. If you're using Olama, then you have to execute this. Okay, so LLM created, and then let's query. So I'm going to query and print it. So this is the line that sends the message to LLM, which we have created here via LangChain library. And this is the line that triggers the tracing and the monitoring through LangSmith. So let's do this. So usual response, let's go back to LangSmith, and you go back from here and go to tracing projects here. Now, if you have set up everything correctly, then you'll be able to see your project that you have defined. So this one, this, okay. So whatever name you have given here, you should be able to see appearing here, okay. And then you click this, and these two are the previous run which I did some time back. So I was testing. So this is the latest run, okay, this one, and it gives you some summary stats here. So it gives you what kind of model I'm using, what is my input, what is output, if there was any error, start time, and latency, end time, and number of tokens which I have used. Okay, if you click this one, it gives you more detail. Then you can drag it. Okay, so by default this is how it's going to appear. Okay, so it gives you input what we have sent to the model and output what we have received. So by default it gives you human readable format, but actually if you click this down arrow and select raw input, it will show you what exact message was sent to model. Okay, and similarly output, you can select raw output, and then it will tell you what kind of message, exact message which you received from the model. Okay, and then there are other information also provided, like for example, if you click on metadata, then it provides metadata about your call. So this is the deployment in case of Azure. Probably in OpenAI case, if you're calling directly, you won't see it, but in my case I can see that this is my deployment ID, and then what is the temperature, what is the provider and model I've used, and the versions of the software. Okay, so this is the trace it provides. Okay, let's try something else. So let's go back and let's try the chain, this one. All right, so I'm going to let me clear this thing. I'm going to create a prompt. Okay, and then I'm going to run the chain. Okay, let's go back. Now you see, this was our earlier call, and this is the latest call. Now in this case, as you can see, it's not saying that is Azure Open Chat OpenAI call. It's a runnable sequence. Why? Because we are not directly calling the LLM, but we have created a sequence, a pipeline, a sequence of steps, and that's why it's telling this is a runnable sequence. Okay, and similarly, it provides metadata. So if we click this, it will provide us more detail, but in this case there is hierarchy. Okay, so runnable sequence contains all the child sequences, if you see. Okay, so this is a runnable sequence, which is nothing but chain. This is our template. This is called to LLM. So now this is our template, and obviously we have two variables, so it's shown here. Okay, and this is what the prompt after the formatting of the prompt, and then this is the call, this is the input, system, human, and this is the AI output. So remember we may discussed that there are three type of messages we are interested in generally. There are more than three. There are actually LangChain provide two more message type, but we'll look at them later. For now, we are interested in system message, which defines the model characteristic, the human message, actual query, and the output that we get, which is the AI message. This is what it's giving. Okay, so again, we can see the raw input. So message type, you can see here it's a system and it's a human, and we can see this one as well. So this is the output message that we have received from the model. Okay, then third step was this was input to our output parser, and this is the output. So extracted this message. So as you can see, you can trace it and debug it if there is any problem, or tracking can be put, like what's going on, how many messages are being processed. If there are any errors, then LangSmith also provide a API through which you can query the LangSmith metadata and build your monitoring system on back of that as well. And probably in the commercial application, that is the best way to go forward. But this is the concept. I just wanted to show to complete the cycle, like when you put your application in production, then how do you ensure that you are able to monitor it, and the LangChain provides a facility to do that via LangSmith. Okay, so let's go back to our slides. So now we have completed all the fundamental concept, and this is what we need to complete our application. Now I want to mention few more concept because prior list is very basic and fundamental concept, and these are the concepts which is also for building a complex application. We need to know them. We are not going to cover them in this or the next video, so these will be the subject of future videos when we talk about building a chatbot, when we talk about building a RAG application or agentic application, then we are going to talk about them. And remember, these two lists which I have shown, this is not the exhaustive list of the components or the functions provided by LangChain. It's more than that, but this is where we are going to start, and we will learn just enough to build the applications, and as and when we need more, we are going to learn more. So I think this should clarify most of requirement for LangChain that we need to build our application. And then in next video, we are going to do a quick tutorial on Gradio. Once that is done, the following video will have a full walkthrough of our application, which we discussed in prior video, right? Okay, till then, see you, bye.